On Capecchi's Corner today, we're going to work with systems of linear inequalities, and today is day 1. Now, in previous lessons, we have graphed linear inequalities. We just haven't worked with systems yet, so that just remember a few things. This time when we graph, we're going to do both inequalities are going to be on the same coordinate plane. And the solutions, we have several solutions, infinite number solutions. They're going to be all points that lie in the common shaded, or we like to call them overlapping region of the graph. Now, as a reminder, dashed lines are used when the inequality signs are greater than or less than. Solid lines we are used when we have greater than or equal to, or less than or equal to. And we shade above the line when we have greater than or greater than or equal to. And we shade below the line when we have less than or less than or equal to. Now, the last thing to remember when dealing with inequalities is if you multiply or divide by a negative number, you're going to change the direction of the sign. Change the direction of the sign. So, for instance, if we have greater than, we're going to change it to less than. Okay, so let's try to graph a system of linear inequalities. So our first inequality says y is less than or equal to 1/2 x plus 2. So let's identify a few things. My y-intercept is equal to 2. My slope is equal to 1/2. Remember, if my numerator is a positive, I'm going to go up. My denominator is positive, so I'm going to go to the right. Other things to notice, because of this less than or equal to, I know I'm going to have a solid line. And I also know that I'm going to shade below. So all those things will be important. All right, so let's start graphing line first. So I have my y-intercept is 2, so I'm going to start here. I'm going to go up 1 to the right 2. So I'm going to do that several times so I get a nice accurate line. Do the same thing in the other direction, down 1 to the left 2. And now I have a solid line. We've already identified that, so I'm going to graph that. Put my arrows on the end. Now I said to shade below, so now I'm going to shade below. And different colors is helpful even when you do that on your own. Color pencils are perfect. So there's my first inequality. Now I need to do my second inequality down here. So let's label what we have. So my y-intercept is equal to -3. My slope is 3, or 3/1. So again, my positive numerator tells me I'm going to go up. My positive denominator tells me I'm going to go to the right. Because I have greater than, I know I'm going to have a dashed line. And I also know that I'm going to shade above. Okay, so it gives us a lot of information to start with. So I'm going to start at -3. I'm going to go up 3, 1, 2, 3 to the right 1, and then up 1, 2, 3 to the right 1. I'm going to keep going so I have a nice idea of where the line is going to be. So I know I'm going to have a dashed line, so I'm just going to kind of dash this all the way through my line. Again, arrows on the end. We said shade above. Now that's always the tricky part, which one is above? I like to say that wherever you place the marble, if it would stay on top and roll along the line, that's above. So in this case, this would be above. If I would put the marble on this side, on this line, it would drop right to the floor, so that's considered below. So again, if I shade above this blue line, I'm going to get all in here. Now the system of inequalities, I have to look at that overlapping region, which looks like it's right in here. So that really is a solution. So I need to, I like to shade it again using a different color. You can use a different color pencil, or sometimes, you know, you just shade what you have darker. So I'm going to use this kind of gray looking kind of marker. So that's considered, that is right there is my overlapping region. So let's just mark that. That right there is my overlapping region. So that is my solution to the system of linear inequalities. Let's look at the next system of linear inequalities. So our first inequality is not in a form that's easy to graph. So I need to get y by itself. So I'm going to subtract x to either side, and I have -y is less than -x plus 9. Now remember, I don't want -y, I want y. So I'm going to divide everything by -1. But I have to remember when I do that, I need to change the direction of the sign. So that becomes greater than. I have y is greater than x minus 9. So let's graph that one. So I know that my y-intercept is equal to -9. My slope is equal to 1 over 1, so that means I'm going to go up and to the right. And I also know because it's greater than, right here, here's my final inequality that I'm going to graph, it means it's going to be dashed, and I'm going to shade above. So I'm going to keep all those things in mind. So I'm going to start at -9, which is my y-intercept. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm down here. And my slope is up 1 to the right 1. So I have all of these pieces here. Now I know it's dashed. We talked about that earlier. And I know I'm shading above. So all this in here is going to be shaded. Okay, so now I'm ready to work with my blue line. So again, I have to get y by itself. So I have -2y is less than -2x plus 6. Divide everything by -2. And again, when I divide by a negative number, I need to change the direction of the sign. So I have y is greater than x minus 3. So again, my y-intercept is going to be -3. My slope is going to be 1 over 1, so that's up and to the right. And again, I notice that I have a greater than sign, so that means I'm going to have a dashed line. And again, I'm going to shade above. So we'll start at -3, up 1 to the right 1. I'll do the same thing in the other direction. And put a dashed line. Now again, I'm shading above, so that's going to be all in here. So again, this is kind of an interesting one here. You have to be careful because I notice in between my two lines, just the pink is shaded. So it looks like my overlapping region is actually going to be above that blue line. So I need to make sure I mark that. So again, it's going to be this part right here above both lines. This gray area is going to be the solution to the systems of linear inequalities. Okay, looking at the next one, I have a lux, which is going to be a vertical line because I only have x. And I also have my blue line here is also going to be a lux, so that's a vertical line. And my y value, I know that's a hoi, right, that y there. So it's going to be a horizontal line. So I just really have to be careful when I'm graphing. Okay, so I have x is greater than 4, greater than or equal to 4. So let me put my line there. So I have 4's here, and I can draw my line right there. Arrows on the end. And again, I'm shading to the right. Now if I switch to my blue inequality, that's going to be 8, which is here. Now this is going to be a dashed line. Now this is going to be to the left. X is less than 8. So it's really going to be all this part here. So I have to be careful. I'm also including, there's my overlapping region so far. I have to be careful. And my last one, y is less than 2. Again, that's a dashed line at y is 2. And I'm going to shade below. So everything is going to be in here. So it looks like my overlapping piece is right in here. So I'll shade that in gray. So that's my solution to the system of linear inequality. Okay, so for our next one, I have y minus 4 is less than 4. So again, I need to get that into something I can use a little easier. So I'm going to add 4 to both sides. And I have y is less than 8. So again, I know that that's going to be a horizontal line. So I'm going to count up 8. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to draw a dashed line. And I'm going to shade below. So everything below that line is a possibility so far. When I go to my blue inequality, I need to get y by itself. So subtract 3x. I have -y is less than -3x plus 4. Divide everything by -1. Now again, I know that I need to change the direction of my sign. So I have y is greater than 3x minus 4. So my y-intercept is -4. I'll start there. My slope is 3. So it's 3 over 1. So I'm going to go up 3 to the right 1, up 3 to the right 1. Keep going. I can do the same thing in the other direction. Down 3 to the left 1. I know I have a dashed line, so I'm going to dash that through. And I know I have a greater than, so I'm going to shade above. So it's going to be everything above the line. So again, I need to find my overlapping region, and that's where both of them are shaded. So I have to stay definitely below that horizontal line. So I'm going to be in here, and then I'm going to be all the way kind of in this region on the left-hand side. So again, that's my solution to the system of inequalities. Now we're looking at a word problem. It says you are planning the menu for a restaurant. Each evening you offer 2 different meals and have at least 240 customers. Tomorrow you plan to offer roast beef and chicken parmesan. The beef costs $5 per serving and the chicken costs $3 per serving. You have a budget of at most $1,200 for meat for tomorrow. So it says right here the directions, write a system of inequalities that show the various number of meals you could make. So again, I've already listed what I know. I know I have at least 240 customers, so it's 240 or more. I also know that the cost of beef is $5 per person, chicken is $3 per person, and I can spend at most $1,200. So I can spend up to $1,200, but nothing more than that. I've also assigned X the number of beef meals and Y is the number of chicken meals. So let's see what we have. Again, let's do a quantity. Let's talk about quantity first. When I know that I'm going to have 240 people, at least that many customers, so greater than or equal to, and those people are going to buy either, they either want beef or they want chicken, so it's going to be X plus Y is greater than or equal to 240 because I could have more than 240. The lowest amount is going to be 240. I can do the same thing when I'm looking at the money. Now I know it's $5 per person for beef, so I'm going to show that expression as 5X. And I know that each chicken meal costs $3, that's going to be plus 3Y. And I know I can only spend up to $1,200, so it's less than or equal to $1,200. I can spend $1,200 and I can spend less than that, but nothing more. If we go back to our question, it just says write a system of inequalities, which is what we did. So my system of inequalities is X plus Y is greater than or equal to 240, and 5X plus 3Y is less than or equal to 1,200. Our last problem for today says to be a flight attendant, you must be at least 18 years old and at most 55 years old. You must also be between 60 and 74 inches tall. Let X represent a person's age in years and Y represent a person's height in inches. Write a system of linear inequalities showing the possible ages and heights for flight attendants. So again, we know that the age, we're between 18 and 55, and we also know that they told us that that's going to stand for X. Our height is between 60 and 74 inches, and again, this time they tell you in the problem that Y is going to be your height in inches. So if we first look at our age, we're between 18 and 55, so I'm going to write 18 here, 55 here. I know X is my variable that stands for the person's age in years, and I'm allowed to be 18 and I'm allowed to be 55, so I have to make sure I include those ages. So I have 18 is less than or equal to X, which is less than or equal to 55. Now we'll do the same thing for Y, which is the person's height. It says you can be between 60 and 74, and again, both of those heights are included. So I have 60 is less than or equal to Y, which is less than or equal to 74, and that is my system of linear inequalities.